Alright, now we're going to talk about how to actually measure and assess urine protein. And so it's worth revisiting the normal range. Remember, normally there is less than 150 milligrams of total protein in the urine per day. Likewise, there's less than 30 milligrams of albumin in the urine per day. So the urine dipstick is something you're probably familiar with for point-of-care testing. So each little pad of the dipstick has a reagent that performs a colorimetric reaction for different analytes. And so there is one that specifically is interested in proteinuria, but actually it only reacts with albumin. So albumin in the urine will change color in response to the reagent on this section. And so it is graded in sort of a semi-quantitative manner. So when you're looking at this result, keep in mind that a technician dipped this in the urine and then is looking at the color change and making some sort of guess about what the color is. And so it could be graded on this following scale. It could be negative for protein. Maybe there's a trace change. And then if it's positive, it's graded on the scale from 1 to 4 plus. And it appears that the concentration of albumin in the urine falls along the grading scale accordingly. So if there was trace, maybe there was 15 to 30 milligram per deciliter. And then you can see as the amount of albumin increases in the urine, the color changes more strongly. But keep in mind, I want you to look at the units here. So we're basically just measuring the concentration of albumin in the urine. In terms of what we determined as the normal range, we're talking about amounts excreted per day. So this is just talking about concentration in the urine. This is important because the color change here is highly dependent on the concentration of the urine itself. So highly concentrated urine would have all the solutes and analytes and proteins be at a higher concentration than otherwise. Highly dilute urine, all the concentrations would be lower, right? The actual content excreted per day may be the same from day to day, but this is very concentration dependent. So that's one thing you really have to take into account. So the way I would do this, remember that there's another piece of the dipstick that measures specific gravity. So I'd be taking a look at that as well. In general, if there's probably 2 plus, 3 plus, or 4 plus on the dipstick, that's pretty predictive that there's actual, true albuminuria. Maybe if it was trace or 1 plus, I'd be looking at the specific gravity and maybe only paying attention if it was the specific gravity was low or normal. But if it was very, very concentrated, I may not be as interested in thinking that there is true proteinuria. I did want to mention some of the limitations of the dipstick. There are some things that can cause false positives. So if the patient just received radio contrast, you'd have to wait at least 24 hours. Otherwise, it could cause a false positive change on the albumin piece of the dipstick. Also, highly alkaline urine can do this as well. So urine pH that's very high, above 8 or so, can do this. And then gross hematuria can do it as well. So those are the main false positives I want you to keep in mind. And just to put this down here, remember all of these interpretations are concentration dependent. Alternatively, you could actually quantify the urine protein by doing a 24-hour urine collection. And so this is where you give the patient a large jug, and usually they come with instructions. The patient will take it home and pick a day when it's feasible to do a 24-hour urine collection. Basically, they'll start at maybe the first void and collect all of their urine in this one jug and do it for a 24-hour period, and then return it to the lab to be processed for the orders that you put in. So as you can imagine, this is the gold standard for measuring urinary protein. Think about it. You're going to get a total volume of urine provided, and then you can measure the concentration of protein, concentration of albumin, and then the concentration of creatinine in that urine sample, and basically get total amounts. So you'll be able to determine the total amount of protein that was excreted, the total amount of albumin, and the amount of creatinine excreted. That's helpful in estimating whether or not it was a complete collection or not. Maybe you could do math and figure out what you would expect the patient's urine creatinine excretion to be, and then compare it to the collection. And that gives you a sort of a rough estimate of whether the collection was actually done properly or not. So even though this is the gold standard, it's just not very convenient for both the patient and the provider. In general, if I was seeing a patient and I needed to measure urinary protein, I saw them there in clinic, I ordered the 24-hour urine collection, they have to leave, do the collection, and bring it back. So it just requires 2 visits for them. The second one being dropping it off at the lab, and some places they have to pay for parking and whatnot. So that could also drag out the actual evaluation. You may not get the 24-hour urine collection back for days or weeks. And then also errors with collection. So the patient could undercollect or overcollect. They could, too much urine will overestimate the total protein. Undercollection will underestimate it. And so there's just too many variables. And so 2 visits are required. It's a little cumbersome for patients. Errors with collection. So we tend to not do this so much in the outpatient world. I tend to order this on the inpatient side just because the patients are sort of captive for other reasons, and in the hospital it's easier for nursing staff to ensure an excellent collection. However, what is actually useful, especially in the outpatient setting, is getting the spot urine protein to creatinine ratio. And so what this does, it estimates the total amount of protein or albumin excreted per day, and by dividing the spot urine protein or the spot urine albumin by the urine creatinine, you're actually correcting for the concentration issues that we had for the dipstick. And because you could get it on the day of the visit and have the results by the end of the day, you actually can act on something or give the patient counseling based on what you find the same day without having to wait for something like a 24-hour urine collection. So the benefit of this is that urine creatinine concentration accounts for the urine volume in such that it will correct for a very dilute or concentrated urine. But this does assume the daily creatinine excretion for everyone being tested is about 1 gram per day or 1,000 milligrams. Obviously, we know that daily creatinine excretion varies for different people, and that's all dependent on muscle mass. So this is quite a big assumption. But here's how we would interpret the spot urine protein creatinine ratio. So if we ordered a urine protein creatinine ratio, the UPCR, and it gave us a result of 2,500 milligrams per gram of creatinine, that's about equal to a daily protein excretion of 2.5 grams per day. So that's high. Also, if we ordered the urine albumin creatinine ratio, let's say we're only interested in albumin, 3,000 milligrams per gram of creatinine, that's about equal to 3 grams of albumin being excreted per day in the urine. So this is how we use these ratios. And like I said, it assumes that creatinine excretion is 1 gram per day, and so that makes the math pretty easy. So the spot protein creatinine ratios are very convenient for clinic because nearly every patient can provide a urine sample shortly after seeing you. It's great for follow-up for patients who have proteinuria. So some of the guidelines will say maybe for the initial evaluation of a patient with proteinuria, you do the 24-hour urine collection. Remember, it's very important to be able to rule in or rule out disease at that point. So going with the gold standard first makes a lot of sense. And then for the patients who have proven proteinuria or albuminuria, for follow-up, you want to monitor that proteinuria, and especially if you're starting ACE inhibitor or ARB, you want to understand whether or not the proteinuria is getting better or not with your therapy or other immune suppression perhaps. And so for follow-up, it's very convenient to do the spot protein creatinine measurements, especially in clinic. And then you're probably wondering, does it correlate to that 24-hour urine? And it really does. It does correlate pretty well to a 24-hour urine protein measurement, but it does seem to lose its accuracy in patients who are not really excreting a lot of protein. So it seems to lose it with less than 1 gram of protein per day in the urine. That's probably where the accuracy decreases. And so maybe for those patients who are sort of in a gray area with not a lot of protein excretion, and especially you want to rule in or rule out disease, they may be better suited with a good 24-hour urine collection. Okay, one more thing worth mentioning is that those spot urine protein to creatinine ratios, they're going to be less accurate if the daily creatinine excretion is not that magical 1 gram per day. So basically what I want you to do is think about the muscle mass of your patient. Remember that creatinine production is proportional to the amount of muscle mass in the patient, and then creatinine production will be equal to creatinine excretion. So if there's anything that's going to affect how much creatinine is being produced, it's going to be muscle mass. And so for patients who have extremes of muscle mass on any side of the spectrum, that's going to affect how this test is interpreted. So for most patients, let's say this patient in the middle here, who have normal amounts of muscle mass, it's probably okay to assume they're excreting 1 gram of creatinine per day. And then everything we said before about the protein creatinine ratio or spot albumin creatinine ratios would be accurate, okay? But what about, unfortunately, some of our patients have very low muscle mass, right? So patients who are malnourished, or patients who have some muscle wasting diseases, or maybe they've had amputations. So if they have less muscle mass, they'll be producing less creatinine than this guy. And so in this situation, a spot urine protein creatinine will overestimate the amount of proteinuria because the denominator is smaller than what we would expect it to be. The opposite is also true. What about this patient, this bodybuilder type person who has large amounts of muscle mass? And in this situation, the urine protein creatinine ratio will underestimate the actual amount of proteinuria. So doing the spot measurement would underestimate it because our denominator is now larger than what we are assuming with the general population. So in this situation, I want you to just think about muscle mass of your patient. And when you're interpreting the spot ratios, you can always, fudge it up and down in your head. But remember, if you actually want to truly know, that's when you would want to get a 24-hour urine collection for quantification of protein or albumin.